Welcome back from Thanksgiving. How's everybody doing today? Good, good. Glad you're here. Good. Did you guys have a good Thanksgiving? Yay. Excellent. Hopefully you took some time and got some rest. Enjoyed a little bit of food and family time. Anybody have anything fun or special they did that week? Oh, that's nice. Yes. Camping. Oh, that's fun too. See, fun family time. Oh, see, isn't that fun though, just to have that time to spend with people you love and do fun things and just not have to worry about the everyday stuff? I feel like Thanksgiving is a great time for that, just to be able to spend time with the ones you don't always get to see. That's usually a good opportunity for that. Okay, so then the other question is, how many of you have kind of fun family traditions that you've either already started or are getting ready to start as we're in Advent season and headed toward Christmas? Got any fun family traditions? Nope, not really. Feel like that's the time of year where a lot of people's traditions are going strong right after Thanksgiving. Okay, so Christmas tree's already up. Yay. Big Christmas party. Nice. Is it near Christmas? Is it kind of in the interim between? When do you do your partying and celebration for that? Right before Christmas. Okay. Nice. Okay, it's about that time. I know. I would say like we were gone for the duration. We literally got home late last night, but I like to be able to do our tree this past weekend, which we didn't get to do. So um, it will be a mad dash to try to get that up. But I always tease my boys are older now. They're your age and older. So I always tease them. I'm like, well, if we don't get it set up early, then we'll just leave it up extra late, and it'll be later when we take it down or something, just as a way to kind of make up for not setting it up early enough. It's got to be something like that, right? Got to have some way to have entertainment with all of that fun. Yes. Okay. So if you do not have your graphing calculator today, you will want it because what we're going to learn today is some information about graphing. And the hope is that you will not have to use your calculator. See, I'm with you, Micah. I could be right there. But the hope is you will not have to use your calculator by the time we're finished with learning about the graphs. But sometimes, especially at the beginning, you guys are unfamiliar with your calculators. So you would like to know how to use them if you want to. So I will explain some of that as we're going along, teach you a little bit about your graphing calculator. But again, I'm not requiring you to use your graphing calculator for these because I want to teach you how to learn the graphs, learn what's happening, so you don't need the calculator. You don't feel like you have to rely on it. Some of us, if I just said, "Hey, here's some information, tell me about this graph," you're like, "I don't know anything about it." That's what we're trying today to teach you is how do we learn about these graphs? What do they mean? What do they show us? So that we can be more prepared, understand a lot more. If you remember, we've kind of skipped a few lessons here and there during the first part of the book. And so, what we're trying to do is to bring all of these lessons together with this unit, with what we're talking about right now, and help you see how you can use these same skills, these same pieces of information for any type of graph. So that is one that I do hope you feel more comfortable with. I do hope that you get to where you don't feel like you need a calculator to help you. You don't feel like you need um, more support with it. The goal here is that you don't need that, is that we would um, teach you what you need to know so that by the end of this, you know what a graph is going to look like, you know what to expect without ever having to use it. But I do want to teach you what you need to know. So if you have your calculator, it will be helpful. If you don't, I'm going to show a good amount of what we're doing here in our graphing calculator online. So don't stress, don't worry if you don't have it. We'll show a lot of it to help make it a little more interesting for you. But I think a lot of us prefer when we can have the calculator there in front of us and use that to be able to get more information from it. So we'll go ahead, we'll say our word of prayer, and then we'll get started on what we need for our graphing. Let's start. Dear Heavenly Father, I thank you for this day. I thank you for all that you have given us, God, and just for the many blessings that we receive every day, God. We just lift up your name and praise you. I thank you for a season of thanksgiving and gratitude where students were able to spend time with family to just rest and re-energize and enjoy time together. And God, I pray that you would give us just grateful hearts during this season of Advent, that we would be not only thankful for your Son, but thankful for the everyday blessings that you give us. God, we know that you are so faithful and that you have provided so much for us. And God, I just lift up your name with praise today for that. I thank you for the families that are represented here. I thank you that they are able to continue to join, that they are able to learn. And God, we just pray that this season we would lift you up, we would glorify you in the things that we do, the things that we say, the way that we serve others, love others, God, that it would just point people to you. Be with us during our class today, and we thank you for all of the opportunities that you give us. We ask all of these things in your name. Amen. All right, so let me get our classroom going here. The notes are here in case you don't have um, access to what you need here. Let's see here. So for this, let me put, I'm going to show you what my graphing calculator looks like, because at the very beginning, I'm going to show my stuff on here as well. And I don't want you to If you don't have a graphing calculator, I don't want you to miss out on what we're doing. But again, I think you will enjoy it more if you have your own. So, excuse me. So, what we're going to talk about today are going to be what we call parent functions. So, when we're talking about parent functions, what we're looking at here is kind of this little, sorry, my camera looked a little crazy there. It took Thanksgiving break too. Okay, so what we're looking at are these different types of equations creating different graphs. So, for example, you'll see that there are 6 here on the board. And what we're going to look at, I'm going to cover up my camera just for a minute here so I can show you my graphing calculator as promised. Okay, so what we're looking at when we have these is we can take just an understanding of what these graphs look like, and we can use that to say, okay, if this graph is created from this equation, then when I do these certain things to the equation, it causes these other things to happen on the graph. So that is what we're going to look at when we graph them on our calculator, which I'll bring my little graphing calculator back out here again. But when we graph them on our calculator, what we're going to see is just by changing things on the equation, certain things will change on the graph. And those certain things are actually very predictable. So if we can learn what things change on equations, we can then say, oh, now I know what the graph should look like. But that all starts with an understanding of these parent graphs that we have out here. Some of you may have seen these before. For some of you, these may be new. I'm going to treat them like they're new. So if you already know this, fantastic. But my guess is that many or most of you don't know this already. So I'm going to go through each of these parent functions on the board. There are 6 listed here. There are actually more than 6, but here are 6 listed so that you can begin to see an equation and the type of graph that will match it. The one that we've been working on is this first one, this linear function. Basically, when I have an equation that has y equals x, I could have other numbers in there, but no more variables, no more exponents, nothing else like that. So it could say like y equals 2x plus 5 or y equals 1 half x minus 7, but no x squared or square root or absolute value or anything like that. Just y equals x. That's going to create some type of line. That's why we call it the linear parent function. Okay. That's the one we've been covering. We've talked about the number in front being its slope. We've talked about changing its y-intercept. But we've looked at lines for a good amount of time during the first half of the semester. Okay. Okay, our next type is going to be what we call the quadratic parent function. And that's going to have y equals x squared. Now, for this one, I could also have an x in it. So it could say something like y equals x squared plus 5x plus 3. Or it could say y equals x squared minus 7. Or it could say y equals 1 half x squared plus 7x plus 14. But for this one, x squared would be my highest exponent on a variable. When I have a quadratic or an x squared, that graph is going to be that U-shaped graph that you see there called a parabola. I've got all of these both here and on your notes so that you're a little more comfortable with what's happening with them. Okay, so that's our quadratic graph. Excuse me. Our next one is our cubic graph. For this one, my highest exponent is going to be x to the third power, or x cubed. So again, I could have an x cubed and an x squared and an x and a number as long as there's no exponent higher than x cubed. Okay. When I have one like this, it's like somebody took that parabola and they bent one of the sides down. So instead of having that U shaped, part of it is still facing up, but now the other part starts facing down. Okay. That is a cube or a cubic graph. Okay. Okay, the other group that we're going to be looking at, we're going to look at two of them. I'm not going to talk too much about the cube root other than knowing that it's there. There's one other one that I will talk about that's not listed here, but I'll put it on the board in case you want to put it in your notes. Okay, okay, but our next one is an absolute value graph. So I make a big point to make that sound and associate in your brain that when you have the absolute value, you remember that it is a V-shaped graph. The absolute value is a V-shaped graph. Okay. Then the next one down below it is called a radical graph. That's just a square root. So a square root will start and just kind of go up and over towards the right. Okay. A cube root has that part of it, that part that goes up and over to the right, but then another part that goes down and over to the left. Very much like you kind of flipped that cube graph, that cubic. And then as promised, the one type that I did not put up here, it is in our class page, but I want to make sure and at least talk to you about it, is a radical graph. So that looks like y equals 1 over x. You'll know this one because it's the only one where you have x down in the denominator. Okay. And then instead of drawing it, I will pull out my little graphing. Maybe I'll pull it out here. If it decides it's going to come out here, maybe I'll show it to you. There it goes. Sometimes, like, having a stubborn child here. When I graph this, it looks like that. Okay. This is called a radical graph. No, I'm sorry. Let me push it on. This is called a rational, which I will write on the board because I know people don't feel comfortable with spelling. There, I'll put it where you can see it since I kind of covered it up showing the graph. Can you see it over there on the left side? Okay. Figure if I cover it up with the graph, it doesn't really help you be able to write it down. So let me try that again and put it over here. Make it stand out a little bit. How's that? A little better, hopefully. And then the graph looks like this. You have two branches of this graph. One that goes kind of in the first quadrant in the top left, and then one that goes over in the third quadrant, which is the top right and the bottom left. Okay, so for a lot of us, this is probably the hardest part of what we're going to do today is learning the new graphs. It By the time we're finished with this week's lessons, it will be easy for you because you'll have used them several times. But right now, you may be looking at them going, that's a lot. I don't know a lot of those, or I don't know any of those. But that's okay. Don't worry. Okay. So if it is the parent function, yes. And you'll see why, Amalia, that I'm hesitating on that question a little bit because what we're going to do today, and you'll see here in just a minute. Okay. So These parent functions that I have here on the board, I'm going to put away the graphing calculator for a minute so I can at least talk to you that way. Okay, so these parent functions that I have here on the board are the originals, right? So these are the unaltered, unchanged, basic parent functions. What we're going to look at today is okay, what if I make changes to those parent functions? What happens? And one of the things that a lot of times, many, many books, including ours, don't really connect the dots for you about these types of graphs until you get much further in math. And I decided pretty early on, you know what? If I can begin to help you understand some of these basics of graphing and realizing that all of these graphs, even though they look so very different, operate on the same basic principles, it might help you understand a lot more about these graphs. Because a lot of the lessons that we've skipped along the way, I've basically compiled them all into one tiny little mini unit that we're going to talk about today. Because what your book would do is okay, so we're talking about lines right now, then it would teach you about how to graph a line. And then we'll talk about quadratics, it'll teach you about how to graph a quadratic. And then we would talk about cubics, and it would teach you how to graph a cubic. And talk about each one of them individually. And what I like to do instead of talking about each one individually is to bring them all together and talk about them as a group so that you realize they all have the same rules. They all work in a very similar way. Okay. So these are parent functions. These are like the starting graph. What we're going to do are called transformations, which means we're going to take the starting graph and do something to it. We could move it, we could flip it, we could stretch it. All of these are examples of transformations. That's what we're going to look at in our examples. So let's start with these four. Okay. If you want to graph them in your calculator, please do that. But for this part, I'm going to turn off my camera so that I can sneak our little graphing pod in here because I want you to be able to see the graphs whether or not you have your calculator. Okay. Okay. So we're going to graph 4 examples. But before we do, let me slide this out of the way for a minute. Before we do, I want you to look at the equations. All the equations are very similar, but I want you to look at the equations and I want you to tell me what type of parent function all of these equations have. What type of parent function are these? Thinking about what we just talked about. It's in your notes as well. What type of parent function do these all have? Anybody see it? Tried to hide my little graphing calculator out of the way for a moment. Good, there we go. If you look, they all have an x squared as their highest exponent. So that means the parent function for these is a quadratic. Okay. And if our parent function is a quadratic, what does the graph look like? Very good. If it's a quadratic parent function, they all have that U-shaped graph called a parabola. Are you okay with kind of how we started this? They all have that x squared. It's called a quadratic, which means the graphs are all going to be U-shaped graphs. Comfortable with where we pulled that information? Good. Okay, so now here's the time. If you have your graphing calculator, you can graph these on your calculator. If you don't, I'm going to put them on the screen. So when I do this, I'm going to type on Desmos, which is the online graphing calculator you see here. I'm going to type them here, but I'm going to talk you through how to put them in your calculator. Okay. Okay. So for the first one, well, first of all, if you want to graph on your calculator, turn it on and you're going to hit the very, very top left button that says y equals. Okay. So turn it on, top left button says y equals. If you have anything there, you probably want to clear it out so that it doesn't accidentally give you a problem when you graph it. Okay, let me move my Desmos pod here for just a minute so I can show you the calculator. When you click on your y equals button, it should come up with this menu. Okay. This is your graphing menu. Basically, this is where you will type your equations. Okay. So I would not put them all in at the same time. I would just one at a time. In Y1, you're going to type in x squared plus 7. Okay, so on my version of the calculator, and most of them are super similar, there's two colored buttons over here on the top left. The bottom colored button right next to it, that is the X. And a lot of times it'll say like X, theta, N, all kinds of other stuff, but that is your X. So when you want to type that in, click that and it'll type your X. And then when you want to type squared, if you keep going down that column, right down here is an X squared button. Hold on, let me mirror a little bit so it's easier to see. Okay, so my X button was right here. And then if I go down this first column, here's a squared. That'll be x squared. And then plus 7, you probably already know how to type. So in this one, plus 7. That's what my equation would look like in my calculator. Here, I'm going to get real zoomed in and then it'll come back out. Maybe it'll actually zoom in. There it goes. Okay. So if you want to type that in your calculator, it'll look like this. Then on the way top right over here is your graph button. So when you want to hit that, hit graph. That's what my graph looked like for the first one. If you have graphing questions while I'm talking, by all means, please ask. Please, because I know that graphing can be a little confusing. I know that it can be a little bit overwhelming because it is new, because it is unfamiliar. So please ask as we're going along if there's something you need help with or something I can explain to you. Okay, so let me get on the graphing calculator here. And I'm going to type in my first one. So the first equation we just did was y equals x squared plus 7. That's the one I graphed on there. And then now I put it on the screen for you. Okay, now let's look at our second equation. For this one, you would have to type parentheses. In your calculator, you don't type y equals. It's the y equals menu. So it's actually already there for you. So when you're ready to graph this one, go back to that top left y equals button. Hit your y equals. You can clear out this equation if you want, or you can leave it if you want. If you want to clear it, just hit clear. If you want to leave it, then you go down to y2 and type your equation in there. So a graphing calculator was one of the things that was required for our class materials. But if you don't, that's why I'm putting it on the board so that either way you can see it. Okay, so for this one, you're typing in y equals, you don't have to type that part, but I do. And then x minus 7 in parentheses. And then once you close your parentheses, you're going to hit the little squared button again. And then top right, hit graph. It'll look like this. How many of you are trying to graph it on your own, and how many are just kind of watching the graphing calculator on the board? Good. Fantastic. Okay. Most everybody has told me. Perfect. Okay. So your second graph should look something like this. Now, I'm going to pause in the middle. If you want to do this as well, I'm going to put up that parent function that we talked about. Remember, we said our parent function was a quadratic. So that's just y equals x squared. Remember, we said we were going to think about that like our starting value. So in my equation, I'm going to put up y equals x squared for you. So this is the quote unquote original. For my graph, I make mine different colors to make it easier to see as we're doing things. So if you're looking on mine, the green graph is the original. So I want you to think, what happened to go from the green graph to the red graph? And for this, you're welcome to look on the screen. You don't have to worry about trying to graph it on your own if you don't want to. How did we go from the green graph to the red graph? Now, I'm actually going to zoom out just a little bit because a lot of times we say something really changed, but when I zoom out, you'll start going, wait, it actually didn't. So when I zoom out, that might help you answer my question a little better. How do I go from the green graph to the red graph? Just think about the graphs. So just think from one graph to the other graph. Don't stress on the equation. I try to be real careful when I ask because I know that if we just look at the equations, it can get more confusing. So how do we go from the green to the red? Most of us haven't said anything. So I'm going to zoom back in because if you have to look at the scale that I have this on. Right now it's moving a whole lot more. Oops, let me zoom back in. How do I go from the green to the red? Because remember, I zoomed out to make it easier to see what was happening. Okay, yes, there we go. We went super simple. You moved up. Correct. So think, how much did I move up? Boop. There you go. How much did I move up for this? Okay, so for the first graph, I moved up 7. Okay. All right, how about to go from the green to the blue? To go from the green to the blue. Okay, be more specific. There we go. I went to the right 7. So there, like this. So for this one, I go to the right 7. Okay, so now Doot, doot. Let's look at our third graph. I'm going to take off I'm going to take off the first two. I'm going to leave the parent function. I'm going to take off the first two. Okay, our next one, go back to your y equals menu if you're playing along at home and doing it on your calculator. Go back to your y equals menu. This time we're going to do x squared minus 7. We're going to do x squared minus 7. So put the equation in there first, and then let's talk about what changes in our graph. What do we see that changes from the green graph to the purple graph? Okay. Okay. Agree. Okay. And then there's one final one. I know you can't see it because it's hidden by my graphing calculator, but I'll type it in the graphing calculator. So go back to your y equals menu. This time you're going to type in y equals parentheses x plus 7, close your parentheses, squared. Y equals parentheses x plus 7, close parentheses, squared. Good. Okay. So for this one, yep, I moved it left. I moved it left 7 units. I agree. Okay. Let me hide my calculator away here for a minute so that we can talk. So for this one, I moved it left 7. So let's try to draw, because that's what we're trying to do with what we are learning. We're trying to take these pieces of information and say, okay, what do they mean? What conclusions can I draw? So let's talk first about what would make a graph move up or down. So we call that a translation. It is a vertical translation if we move it up and down. So what would make a graph move up and down? Look at the two that I have there that are moving up and down. What would I change in the equation to make it move up or down? Now it's kind of connecting all of those little pieces. What would I change in the equation to make my graph move up or down? Okay, so there we go. So if I add or subtract a number after my squared for this example, it's all you've seen so far. If I add or subtract a number after my squared, it's going to move the graph up and down. Okay, what would make a graph move left and right? That one's a horizontal translation. It's a tiny bit trickier, but only a tiny bit. What would make a graph move left and right? What do you see? What would make our graph move left and right? Okay, yep, that's what you see so far. There we go. So, what I tell you with this is to think about grouping symbols, right? So, for this type of grouping symbol, it's a parentheses, but it could also be a square root. It could also be absolute value bars. But if you put that number that you're using to move inside the grouping symbols, for this one, it was the parentheses, that's going to cause a left and right movement. What's the trick with left and right movement? Do you see it in the equation versus how the graph moves? What's the trick? Because for horizontal, I'm sorry, for vertical, if I wanted to move it up 7, I added 7. If I wanted to move it down 7, I subtracted 7. Horizontal's got a little trick to it. Anybody see the little trick there? Yeah, some of us are typing. Okay, we're starting to pick up on it. Okay. So for this one, the little bit of trick for a horizontal translation, some of you are still typing. I don't want to talk over you if you're still typing. I want you to have a chance to answer it since I asked. But the little bit of trick for this one is when I subtracted 7, I moved right. And when I added 7, I moved left. So the trick for a horizontal is it's the opposite direction. So when I moved, even though this is a -7, I moved right 7. And even though this is a +7, I moved left 7. So I always tell you, think about it like it's like something you got to pay. The fine you got to pay to get out of jail is you have to change your sign, right? So if you're a -7, you're going to move to the right. And if you're a +7, you're going to move to the left in this example. Okay. I know. I try to explain the tricks. I don't want the tricks to be a surprise. I want you to know what's going on. Okay, let's look at a different type. So now we're looking at an absolute value graph. Before I show you on my calculator on the screen, I want to talk about how to do this one on your calculator because it's a little trickier to type in an absolute value for the first time. Okay, so turn your calculator on. If it went back to sleep, go back to your y equals menu, clear out anything that's there because we're going to a whole different type this time. We're going to do an absolute value graph. So you're in your y equals menu. Flip again here. Always has to change this to make it look right. There it goes. Okay, so when you're in your y equals menu, if you want to type the absolute value, right here underneath the colored buttons, there's a little math button. So hit that. This is also the one like when you're changing a number back to a fraction, like if you have a decimal and you want it to be a fraction. Remember we talked about math, enter, enter, that's the same button. So if you hit math and then you hit your arrow to go over the wrong way, hold on, go over one time there to your numbers menu, that very top thing there says ABS. That's absolute value. So if I hit enter right now, it'll type it right onto my y equals screen. So the first thing we're going to do is just put an X in there and type the absolute value of X. Okay. So type in X, close your parentheses, hit graph. And there's our parent function for this one. That's an absolute value graph. It's a V-shaped graph. Okay, so now that you have an idea for that one, let me bring out the graphing calculator here. Try to get rid of what we don't need. Let's start again. Okay, so we just graph y equals the absolute value of x. Just like on your calculator, I have a V-shaped graph. Okay, if you notice, nothing in any of the examples that I have up here is adding or subtracting anywhere. So will my graphs be moved anywhere? Will they be moved up and down? Will they be moved left and right? So, because nothing has been added or subtracted, they won't be moved left or right. Isn't that helpful? And because nothing has been added or subtracted after the absolute value, they won't be moved up and down. These will not be moved at all. We're going to change something different this time. So now go back to your y equals menu. This time type a 3 first, then do that absolute value and type the absolute value of x. Okay. So on the screen or on your calculator, whichever one you see it, what changed from the first graph to the second graph? You can, if you don't have the ability to do it on your computer, I mean, on your, excuse me, on your calculator, you can see it on the screen. Okay. So the way I will describe this, there you go, is that the graph got narrower. Yep. It's like we took the red graph and pulled on the end of it, right? So this is called a vertical stretch. That's called a vertical stretch. Okay, let's try the next one. This one we're going to do y equals, but in front of the absolute value, we're going to do 1/4. So y equals 1/4 times the absolute value of x. So if you're looking at that one, y equals 1/4 times the absolute value of x. Okay, so when I look at this one, what happened here? So I'm going from the red graph to the green graph for this one. How would I go, or what changed when I go from the red graph to the green graph? So from the red to the green. You would just do 1 divided by 4. Yep, there you go. So 1 divided by 4 and then the absolute value of x. Okay. So again, how do I go from that red graph to that green graph? Some of you have kind of said and some of you haven't said yet. How do I go from that red graph to that green graph? Okay, good. Remember to do the absolute value. You'll hit the math button and then you'll hit the right arrow one time. And that'll bring up ABS, and that's absolute value. Nope, not a problem. Not a problem at all. Okay, so for to go from the red graph to the green graph when I use that 1/4, this time I do what's called a vertical shrink or a vertical compression. So imagine that you just, had an elephant sit on the red graph, right? It just squished it. And so if we describe the blue one as being narrower, We described the green one as being wider. It made the graph wider. Can you see how that description fits? Okay, so I'm on the board. I'm going to clear off the blue and the green. I'm going to leave the red because it's my parent function. I'm going to clear the other two off. And I'm going to do my last one. My last one is going to have two changes. So watch for those. So again, back to my y equals menu. I'm going to type in y equals -2 times the absolute value of my x. So this time there were two changes. So y equals -2 times the absolute value of x. There were two changes for this one. What two changes? Yes, that's right. So because I put that negative in front of the absolute value, that caused something called a reflection, right? You've seen those before. And then it also had that vertical stretch that where it got more narrow. Exactly. So the 2 made it more narrow and the negative caused it to flip. Yep. Okay, are you starting to see how all of these little changes in my equation are causing changes in my graphs? In a minute, you're going to feel like so amazingly smart that you're like, whoa, I did not know any of this at the beginning. And now I can take all these little pieces that I know and actually interpret an entire graph. Like it's coming. Okay, so let me. Boop. So here are the four changes that we've looked at. We looked at the translations, we looked at the reflections, we looked at a vertical shrink and a vertical stretch. So this is kind of my place to summarize all of these things before we take our break. Okay. So what I would say on here is what caused the changes. That's what I'm going to type. You don't have to type it the exact same way I do, but I want you to use this slide to help your memory with how these things came about. So what caused a translation? And we had two different types. We had a vertical and a horizontal. So let's do vertical first. What caused a vertical translation where I literally just took my graph, moved it up or moved it down? What caused that? What caused that graph to just move up or down? That's all we were doing with it. What caused it to move up or down? Good. And I'm going to be a little more specific. Mhm. Adding or subtracting outside of the grouping symbols, meaning adding or subtracting after the X. That's another way to say it. Okay. Okay. Then when I did a horizontal slide, horizontal translation, what did I do for that? How did I cause that? Okay, good. So for this one, I would say adding or subtracting inside grouping symbols. And then I'm also going to say change the sign. Just to remind me, if it's adding, I'm moving to the left. And if it's subtracting, I'm moving to the right. These are my notes. This is what I hope you will come back to if you're struggling or you have questions later. So I want to be as specific as I can in my notes. Okay. Okay. How about our reflection? We only saw one, but what caused a reflection? And we'll get a little more specific on reflections here in a little bit. What we saw was a vertical, a reflection over the x-axis. That's what we saw. Put a negative in front of the equation. Okay, that's all we've seen so far. So that's all I'm going to put for my notes right now. Okay, now what caused our vertical shrink? Remember that vertical compression where our elephant sat on our graph and made it wider? Look at our example. What caused the one that made the graph wider? Can you remember? So to cause a vertical shrink, we're going to put a number smaller than 1. We don't care about the sign of it. When I'm talking about smaller than 1, I'm not talking about positive and negative. Remember, the sign will determine the reflection. I'm only talking about the value of that number. So put a number smaller than 1 in front. Okay. So then what would cause a vertical stretch? What would cause a vertical stretch? There you go. Good. That's exactly right. So, why I wanted to end like this before we take our break, I wanted to get all the way here, pause, and take our break because then your brain has a chance to kind of say, okay, I understand what each part does. Because when we come back, we're actually going to start applying it. I'm going to give you an equation. We're going to start saying, okay, what would this graph actually look like before we ever graph it? But for now, we're going to pause, take your break. We'll come back and go through some practice problems here in just a few minutes. All right, so here we go. Let's actually practice some of these. We're going to try kind of putting all the pieces together and see how this goes. Okay, so for each of these, I have a list of questions. Okay, right now, we're not going to worry too much about domain and range. We'll get to that here shortly. But right now, we're going to focus on looking at all of these pieces and figuring out what we think the graph would look like. And then we're going to try it and see. For our first one, what is the parent function? For the first graph that's here, what's the parent function? You see all this craziness going on here. But what's the parent function? Good. There we go. Look past all of the added pieces of it. The equation is an absolute value function. So when I do a problem like this, I'm not necessarily going to have all of these leading questions for you, but this is the stuff that you should be asking yourself. These are the examples of questions you should be asking yourself. Where do I start? What's my parent function? When I do this, not only will I write the equation, I'll also just really quickly sketch a graph to remind me, oh yeah, that's the V-shaped graph. Okay, I got it. Okay. Next, I'll say, does it have a vertical shrink or a vertical stretch? So let me go back to my slides here. Remember, to get a vertical shrink or a vertical stretch, what would we have to do? If we wanted to have a vertical shrink or a vertical stretch, what would we have to do? These are my notes that I can refer back to. Right. I'm going to have some kind of number in front of my absolute value. Do I have that? Because if I look here, my vertical shrink or my vertical stretch involved putting numbers in front. I don't have that. So I would say here, no. Okay. We have not looked at a reflection across the y-axis yet. We will. But do you see a reflection across the x-axis? If you don't remember how to get it, go back to your notes. I would have to put a negative in front of the equation. This one doesn't have a negative in front of the absolute value. So again, a no. Okay. Does it have a horizontal shift? Meaning, has it been translated left or right? Okay. So if you notice inside of that grouping symbol, I have a number that's being subtracted. That means it's got a horizontal shift. So this number right here, let me do something else. That number right there tells me that there's a horizontal shift. So here's the trick. Where does it tell me to move it? We know horizontally, but where? Excuse me. We know it's telling us to move horizontally. Where? There we go. So we said when it's moving left and right, it's going to move the opposite of the sign you see. So it's negative. So I'm going to move to the right. Whoops. I'm going to move to the right 2. Then finally, does it have a vertical shift? Does it have a vertical shift? And if so, where does it move it? So if it's to the left, that wouldn't be vertical, that would be horizontal. Left and right's gonna be horizontal. That kinda helps me visualize what's going on there. Let me go back here. Come on, go back. There it goes. If it's going to have a vertical slide, translation, shift, I'm gonna have to put a number outside of my grouping symbols. So if I look, here I have a number outside of my grouping symbol. That will be my vertical shift. So it's gonna go up 4. I tried to color code this to help you see where each piece of information that I did find, where that's gonna be used. So if I were gonna graph this picture here, we know that okay, I'm gonna try to do this freehand, which is always a bad idea because I'm not that good at it. Pretend that's not horrible. So I start with my absolute value graph. I need to move it to the right 2 and up 4. That's what this graph looks like. So just to confirm, let me pull my graphing calculator if I can wake him up again. Okay, there he goes. I take this guy here. I'm going to type in the equation that we just looked at. And isn't that what it looks like happened? Took my absolute value graph, moved him to the right 2 and up 4. So look at that. At the beginning of class, you probably didn't even really know what an absolute value graph was. Now you're starting to say, okay, not only can I tell what an absolute value graph is, but I can take one that's been changed and start to learn what the new one will look like. Pretty cool, huh? Okay, let me take off my bad graphing here. Okay, let's try another one. Look at our second example. What is our parent function? What is our parent function here? Close. So that 3 isn't in the little tiny index. It's just a number in front. I know it's hard to tell because the whole thing is tiny. So it's just a square root. Yep, it's just a square root. I know it's hard to tell, which means my graph is going to look something like this. Okay, let me go back and write this a little better. So then you can actually still see my question. Okay, does it have a vertical shrink or stretch? So remember to determine that, I'm going to say, yes, it is called a radical. That's correct. So to determine if it has a shrink or a stretch, go back here. What was I looking for? To determine if it had a shrink or a stretch, what was I looking for? I keep going back to these notes to give you a foundation. Okay, so I'm looking for a number that's in front of the equation. Does it have a number in front of the equation? It does have a number in front of the equation. Remember, for this, we don't care about the sign. We just care about the number. So if I look at my number that's in front there, is that number bigger than 1 or less than 1? 3 is less than 1? I know, I'm totally tricking you. Okay. Okay. So that number that's in front, that 3 is bigger than 1. So I know. That's why I said don't think about the negative. That's the trick on this one. Totally confusing for some of us. So if I have that 3 in front, it's like I took that graph and stretched it out. So this is a vertical stretch, okay, by a factor of 3. Next, does it have a reflection? So remember back to your notes, how would I know if it had a reflection? The way that I would know is that it would have a negative in front. So that negative, the reason we don't look at that negative and call it -3 is because that negative tells us something totally separate. The positive or negative tells us one part, the number tells us another part. Okay. So for this one, that negative that's there tells us that it has a reflection across the x axis. Basically, we took that graph, flipped it over. Okay. Next, does it have a horizontal shift? If you go back to your notes, remember something will have a horizontal shift if it has a number in the grouping symbol. So does this one have a horizontal shift? So my grouping symbol for this one is my square root. Is there a number inside my square root? No. So this one does not have a horizontal shift. Okay, does it have a vertical shift? Remember, it'll have a vertical shift if there's a number outside of the grouping symbols being added or subtracted. Okay. So then where does this graph move? If it does have a vertical shift, where does it move? That +2 that's there told me it did have a vertical shift. So remember, to the right wouldn't be vertical. To the right would be a horizontal. There you go. And I'm trying to help get these words more comfortable because I know for some of us these are still kind of like transformations. I don't know what these words mean. Good. So this one has then been moved up 2 units. All right. So let's see if our description matches what we see on our graph. So if I start here, my parent function is the y equals, whoops, square root of x. Okay. And then our new one is y equals -3 square root of x and then +2. So if I'm going from the red one to the blue one, did I stretch it, reflect it, and then move it up 2? Does that look like a pretty accurate description of what we see? Not bad. Well done, friends. Good. Okay. Are you starting to understand how do you do that in your graphic? Oh, the square root. So in your calculator on the far left column where you had that x squared button, do you see how right above it it's in a different color? So to get that one to come, I would push the second button and then type that squared, and it would make it a square root. So anything that's for me in my calculator, it's yellow, but depending on your model of calculator, it might be blue. Anything that's written up there in that color, you just have to hit the second button first and then that button. Of course, absolutely. It's a great question. I'm glad you asked. Okay, so let me jump a little bit. I have some more of these we can practice, but I want to actually look at what a problem might look like on your work this week before we finish up. I want to look at what a problem might look like. So it's going to give me some equation, and then all of a sudden I'm going to go, I don't know how to do this. I don't know anything. I don't even know what's going on. So here's the way I would approach a question like this if I were you. It gives me this equation. All of a sudden I have a panic moment, realize I don't even know what this is. I don't know what's going on. I'm going to say first, okay, what's the shape? Look at problem number 1. What's the shape of this graph, which remember comes from its parent function. So if I look at problem number 1, what would the shape of that graph be? I'm going to show you how I would approach a problem like this. So in problem number 1, f of x is the same thing as y equals negative parentheses x plus 2 close parentheses squared plus 6. Very good. Because this is a squared, that means it's a U-shaped graph. It's the parabola. Okay, that's the first thing I would do. The next thing I would do is identify what each change in that equation does. So I'm going to write over the graph just so that I have more room, and then I'll erase it when it's time. So what would this thing out in front, this negative sign out in front, what would that do to the graph? When we put a negative in front, look at your notes. When we put a negative in front, what does it do to the graph? Good. And it reflects it over the x-axis. And I'm going to put it just like that because I ran out of room to write it all. Okay, next. What does this number in here do? So in my parentheses, I have a plus 2. What would that do to my graph? If in my parentheses I have a plus 2, think about what would that change on my graph. Go back to those notes. Okay, here's where I have what's happening. Okay, so that would move it to the left 2 units. Mhm. And then finally, if I have plus 6 out here, what would that do to my graph? There you go. It's going to move my graph up 6 units. Do you see where each piece of information has an impact in your graph? Good. Okay, so then I'm going to take off my arrows for a minute just to make it easier for me to graph them. Okay, so then I would take, now this is going to be really bad because me drawing on the board, not good. I'm going to take my parabola, I'm going to reflect it or flip it down. I'm going to move it left 2 and up 6. It's going to look like this, sort of. That's what my graph looks like. Not bad. How did you feel about what we did for that particular problem? Did it make sense? Good. And you've got your calculator as a backup. Okay. So, um, you'll eventually be able to get to problems like this. You start with your parent function, you go to some other graph, and now you start talking about, okay, what would happen? So, for example, on the first one, I might say something like, it was reflected over the x, and then it was moved left 3 units. So it's a verbal description. You're just telling me what happened. I didn't ask you to draw a graph. I simply said, what happened? How did it change? Okay. Identifying all those changes helps you better understand what's going on. Okay. Okay. So, last thing for this week. Instead of doing these random lessons from the book, what I did is I pulled some worksheets that involve what we've been doing. Okay. There's one change, so make sure when you print the worksheet, you make the change on one of them. I changed it to one we were more familiar with. So you're going to work through these. There's an answer key there for you to be able to check your answers so that next week when we come to class, we're going to finish up, do a review of our material for the first semester because, as hard as it is to believe, next week is the last week of the first semester. After next week, you'll finish up your work and you'll be on Christmas break. Isn't that crazy? So crazy. Yes, it happens so, so fast. There is. We will take a semester exam, but that's what we'll be reviewing for and talking about in class next week. So, yes, like you just blink. And I told you, once we come back from Thanksgiving, it's like, okay, and we're on Christmas break. Barely a chance to catch your breath, but that's okay. All right, guys. Thank you so much for being here. I hope you feel like super smart because you did great today. I'll see you again next Monday. Have a great week. I'll see you next time.